Hello friends, welcome to B.Sc.Agriculture. If you are coming to my channel for the first time, then don't forget to hit the subscribe button. So let's move to the video. In this video, we are going to see about fundamentals of biochemistry. I am going to teach you unit 2 and the lecture topic is physical and chemical composition of or constants of oil and the rancidity of oils. So while seeing the properties of fat, which is nothing but a solid mass of oil, so while seeing the properties of fat, in physically it is greasy to touch, which is it's like is silky in nature while touching it, and which is almost insoluble in water as well as soluble in organic solvents, is the basic characteristics of fat, as well as the fat which is always tasteless, odorless, colorless and neutral in reaction with everything other surrounding materials, as well as they use it to have a lesser specific gravity, which is the density, than water, so it can able to float on the water. So they are used to broken down into minute droplets when they are dispersed in water, which is known as emulsification. The process of breaking down of great particle into minute droplets in water is known as emulsification. The process is emulsification, which greatly increases the surface area of fat, and they are used to be, which is essential requisite for the digestion of fat in the intestines. So the naturally occurring emulsification is milk and yolk of an egg is a naturally occurring example of emulsification. So while seeing the chemical properties of fat, the first one we are going to see is saponification, which is the alkali hydrolysis of fat is known as saponification. So the alkali salt of fat acid resulting from saponification is soap. So when the alkali salt plus fat is reacted, the final process of resulting is soap. So the sodium and the potassium salts of fatty acids like palmitic stearate and oleic acid and combined with the potassium soaps or which is soft and soluble, and sodium soaps are hard as well as lessly soluble in water. So while combining the alkali with the fatty acids of palmitic, stearic and oleic, you use it to get potassium soaps which is soft and soluble, as well as the sodium soaps which is hard and less soluble in water. So I have given the picture of saponification process in this picture, where the triacyl glycerol, which is a fat, and potassium hydroxide, which is an alkali, used to react and forms glycerol molecule as well as soap, the potassium salt of fatty acids. So after saponification we are going to see about enzyme hydrolysis. So enzymatic hydrolysis of fat is mainly done by the action of lipases. So lipases are widely spread in both plants and animals, and other chemical processes rancidity, which is a development of disagreeable odor as well as taste in fat for a long duration or storage of fat or oil upon a storage containers, which is used to have a bad odor. So there are different rancidity. The first one is hydrolytic rancidity, where the ester bonds of fat, I have already told you in the before lectures. If you want to see, then go and see the hydrolytic density, where the ester bonds of fat is used to be reduced, and the other one is oxidative rancidity, where the oxidation of unsaturated fatty acids, where the fats are used to combine with oxygen and causes breakdown of bonds, is known as oxidative rancidity. And the other process chemical property is hydrogenation, where the selective hydrogenation is done by catalyst as well as the temperature. So you must need to remember that hydrogenation can be only done under the properties in the presence of catalyst as well as temperature. So what are the basic qualities is, the first one is hardening, where the hydrogenation of unsaturated fatty acids use it to make the process of partial characteristics to avoid the process with high melting points. They are used to be carried out in closed containers the process which is used to be taken at 180 degrees centigrade, and the catalyst is removed mainly by filtration. So the mainly used catalyst for hardening of hydrogenation process is nickel at the percentage of 0.05 to 0.02 percentage. So, and the other topic we are going to see is constant of fats and oils. So the fats and oils are used to be identified necessary to be pure fat, and the determined proportion of different types of fat or oil can be determined by the adulterants in the edible oil as fat is like ghee and butter. So while studying the constants of fats and oil, you can able to give an idea about the nature of fatty acids present in fats and oils. So the first one we are in the constants we are going to see about is physical constants. So the first one is specific gravity. Different oils used to have a different specific gravity. So any variation from normal value shows the mixture of oils is present in that particular fatty molecules. And the other one is refractive index, where the definite angle of refraction of is done in the oils. Variation from normal value indicates the adulteration of fats and oils. And the other is we are going to see solidification point or setting point, where the temperature at which the fat being melted and get back to solid is the setting point, where each fat used to have a specific solidification point. And the other one is after seeing physical constitutions, we are going to see about physical chemical constants. So the first one is saponification number. So saponification number is milligram of KOH required to saponify 1 gram of fat or oil. We have used to see the saponification process. The number of grams of potassium hydroxide required to saponify 1 gram of fat or oil is known as saponification number. Higher for fat or higher saponification number for fat or oil used to have low molecular weight and short chain fatty acids, which gives a clue, and molecular weight and size of the fatty acid is inversely proportional to the saponification number. And the other one is iodine number. So the number of grams of iodine taken by 100 gram of fat or oil is known as iodine number. So the iodine number used to measure the degree of unsaturation of fatty acids, so which is used to calculate the relative unsaturation of fats and oils. And the other one is Reichert-Meisel number. We can able to shortly call it as R.M. number. So which is a measure of volatile soluble fatty acids, so confined to butter and coconut, which is mainly confined to butter and coconut oil. So we can able to calculate R.M. number by the number of milliliters of 0.1 N alkali required to neutralize the solubly volatile fatty acid contained in 5 gram of fat is known as R.M. number. So the important to food chemist is which is used to detect the adulteration in butter and ghee. So which is always used to reduce the value in animal fat is used. Animal fat used in adulteration of butter and ghee can be reduced by RM, can be found by RM number. So and the other one is Polanski number. So the main reason for Polanski number is used to find the adulteration of ghee by insoluble non-volatile fatty acids. So we can able to calculate the Polanski number by the number of milliliters of 0.1 N KOH required to neutralize insoluble fatty acids, which is a non-volatile with steam distillation of 5 gram of fat is used to find the Polanski number. So and the other one is Acetyl number, which is a measure of number of hydroxyl groups present in fat or oil. So the acetyl number can be calculated by amount in milliliters of KOH solution required to neutralize the acetic acid and obtained by saponification of 1 gram of fat after acetylization is used to measure the acetyl number of the fat or oil. and the other one is acidic number. So the milligram of KOH required to neutralize free fatty acid present in 1 gram of fat or oil can be able to find out the acidic number. So it used to indicate the amount of free fatty acid present in fat or oil. The FFA content increases with the age of the fat as well as the oil. So I have given the lecture notes in the description. If you have any doubts, please make it commented in the comment section. If you like the video, like it and share it with your friends, and subscribe to B.Sc.Agriculture and hit the bell icon to get regular updates. So thanks for watching the video. Thank you. I will catch you up in next videos.